This is a demonstration of laser-activated transparency switching in a paraffin PDMS composite with an absorbing pigment incorporated. The material, when it is heated, for example, by a beam of high-intensity light, it undergoes a phase transition from a light scattering state to a transparent state, and therefore from a state in which a laser beam will not pass through to one in which a laser beam will be transmitted. In our experiment, we have two light sources, a red laser and a blue laser, which we have coincident on the same point of the sample. The blue laser is absorbed, which generates heat for the phase transition, and the red laser is not absorbed, and so that acts as our probe, gauging the transmittance of the sample locally where the laser beams are incident on it. Right now we have the blue laser beam blocked, and so when we take the blue laser beam and allow it to pass through, the blue light now is incident on the sample, and the absorption of this blue light is generating heat to create a localized phase transition. And here we see the transmittance of the sample going up rapidly at the point where the laser beams are incident, and the red light now being transmitted. At the detector, we have a filter so that only the red beam passes through to the detector. When we take the blue laser and block it, we now see the system begin to return to its original non-transparent state. With the thermal load removed, the reverse phase transition occurs and the material goes back to the scattering state, and slowly the red laser beam begins to be attenuated. The system, in terms of the material, the pigment concentration, and the light intensity still need to be optimized in order to obtain the fastest possible switching into both the on and the off states, to and from the scattering state. But here we see after about 20 seconds, the system has returned to its scattering state, and the red beam is blocked again.